All right, we're going to continue on with verifying trig identities. So this example says we have an identity and we want to change everything to sines and cosines. So we're going to start with the more difficult side, which is the left side. And we're going to change it until we get the secant of x. So we can change this tangent of x using our quotient identity. So the sine of x is going to stay as it is, and then we change that tangent of x using the quotient as the sine of x over the cosine of x. And then we still have plus cosine of x. Now what we're going to do is we're going to go ahead and multiply these two fractions. I'm changing that sine of x to a fraction, so we're going to multiply across. So we're going to get sine squared of x over the cosine of x plus the cosine of x. Now, in order for us to combine these into one term, we want to find common denominators. So I'm going to go ahead and change this to a fraction, and we want to find the LCD. What is the least common denominator for these two fractions? And that is the cosine of x. So I already have a cosine of x here, but I don't down below. So I need to multiply that second fraction by a cosine of x. So this is now going to be cosine squared of x over the cosine of x. So you're increasing that second fraction by a cosine of x. Now the two denominators are the same, so we can combine them together. And how we do that is we add them. All right, next, we have an identity in the numerator. This identity, if I scroll back up, is right here. It's a Pythagorean identity. Sine squared of x plus cosine squared of x equals 1. So I can replace that numerator with 1. Then our last step is to use our reciprocal identity. The reciprocal identity for 1 over the cosine of x is the secant of x. So now just check to see that you've proven the two sides. So we wanted at the end to have secant of x. We have the secant of x. All right, example 3. Use factoring to verify an identity. So we're going to start with the more difficult side, which is the left. And we're going to start with factoring. So we do have a greatest common factor, a GCF, with the cosine of x. So we're going to take out a cosine of x from the left side. So we're going to be left with 1 minus sine squared of x. So we've taken out the GCF. This parentheses is the Pythagorean identity. It's a little hard to see because the Pythagorean identity says sine squared of x plus cosine squared of x equals 1. What we have to do is we have to rewrite that equation. So I'm going to keep the cosine squared of x on the left, and then I'm going to subtract sine squared of x. So this is what's left in that parentheses off to the left. So now we can replace it right there with 1 minus sine squared of x. So I have cosine of x multiplying cosine squared of x. Now when we multiply cosine of x times cosine squared of x, we get cosine cubed of x. So look above. We wanted to finish with cosine cubed of x, and we got cosine cubed of x. Example 4, using two techniques to verify. So I'm going to do this problem using method 1, where we're going to separate a single term, quotient, into two terms. So we're going to start with this side, and we want to get it to be on the right. So I'm going to separate that fraction into two fractions, 1 over the cosine of theta plus sine of theta over cosine of theta. So you're separating it out into two fractions. Now we have identities. The first identity is the reciprocal identity. The second one is the quotient identity. And we are done. We wanted the secant of theta plus the tangent of theta, and we got it. Now we're going to do method 2. Method 2 says change everything to all sines and cosines. So I'm going to work with the right side, and I'm going to change it all to sines and cosines. So what I can do is use my reciprocal identity and my quotient identity. And then these are two separate fractions that I can combine together. They have the same denominator. And we're done. Here is our left side, and we got the right side to be the same.